Okay, so here is the first example. With these questions, as they're graphs or linked to graphs, you usually get an insert. Okay, so I'll come to the insert when I complete the question. As you can see, it's got a table to fill in, and it's also got a graph drawn out. Right, so let's read the question. It says, the relationship between x and y is believed to be of the form y equals kx to the n. Now, it's really important because at some point, it will tell you some information which tells you the relationship they want you to use. And this time is y equals kx to the n. And it says that k and n are constant. Okay, the following is recorded. So we've got our x and our y values and we've got some data. Now, it tells us we want to verify that this here is an appropriate relationship and we want to find the values of k and n. Now, I've always said how it's important to reason your understanding. So the first thing I want to say is if y equals kx to the n is appropriate, I then want to discuss how I will draw a straight line graph. Now, before I do that, I'm just going to have a look at my insert, and you can see that I've got log x against log y. So that's probably what I'm going to end up in there. And I'm just going to go through on my piece of paper, making it extra clear how to write that out, as I've just shown you on that whiteboard. So we take logs of both sides. I'll say log 10y is equal to log 10 kx to the n. And the reason I said log 10 is because it matches up with the insert. Okay, so if I just work this through nice and quickly, like we just have, we separate using the multiplication rule that says that this equals log 10k plus log 10 x to the n. And therefore, log 10y is equal to n log 10x, using the power rule here, plus log 10k. Now, as I said, at A-level you have to reason to the examiner. So if it's appropriate, then this happens. So this implies that if I plot log 10x against log 10y, so this is saying that if we plot on our x and y axes, we usually have log 10x instead and log 10y, then I should get a straight line. Okay, and it's really, really important to show this understanding here with your reasonings. I'm sorry it's a little bit blurry. See, was that a little bit better? Okay, so we'll go on to the insert. Okay, so first thing I need to do is I need to work out the values of log 10x and log 10y. Okay, so we can simply use the calculator, log button there. Oh gosh, put a 4 in. Log 10. Okay, now my first log x is 1. So I'll just put the value of 1 in. We should know that that's just going to be 0. And I might write my 0 in there. And then if I do it of 1.98 to find out the y value, I get 0.29666, whatever. Okay, and if I just look at my scale, it's going up in 0.1, so I don't really need it more than 2 decimal places. So I'm going to call this 0.30. Maybe I'll call it 0.297. Okay, so then I can round it as I plot. Okay, I'm then going to complete this for all of the ones going along. Okay, so I've literally used my calculator to input all of the values for x. So I've input log 2 for this, log 10.3 for that one, and so on. And I'll do the same for y. Okay, so I've finished that off, putting all my log 10y's and did it to 3 decimal places. Really, 2 decimal places would be enough because that's the accuracy of the graph. And now all I need to go along is go and plot my points. So, I apologise if this isn't the most perfect view, but I will do my best. So I'm going to go along. The first point I'm going to plot is 0 against 0.297. So 0 against 0.297 will be about there. Okay, and then going to go to 0.30, which is around here, and go up to 0.143. So 143 will be around there. Okay, then got 0.477, so that will be around here, and then 0.06, so that'll be 4, so that I imagine will be around here. Okay, and then 0.602 with 0.004, so that's just off there. As you can see, we are starting to form this nice straight line, so I'm pretty happy so far. Then 0.699, so that's very, very near the 0.7, and negative 0.04, so let's go down to 0.04 around there. 0.778, so just before 0.8, negative 0.086, slightly more near towards the 9, let's go there. 0.845, about halfway between them, and 0.125, so that's around there. And finally 0.903, so it's about 0.9. And then 0.14, so that's 143, a little bit above that, so there. Okay, so I've plotted my points, and as you can see, they are more or less drawing a straight line, so I'm going to now join those up. Okay, so this is my straight line graph. I'm now going to go back to this sheet and try and work with that to answer the question. So I've written, if I plot log 10x against log 10y, then I should get a straight line, and I'll say, as you can see, I'll write in green, sorry. As you can see on the insert. Okay, so I've verified that y equals kx to the power of n is appropriate. I now need to find the values of k and n. If I look here, I can say that n is going to be the gradient of the straight line. So let's have a look at that bit first. So n is going to equal, make it nice and clear for you, the change in the vertical, which in this case is log 10y, divided by the change in the horizontal. Now what I'm going to do is I'm going to actually choose two specific points. Okay, so I'll choose this one, which I know is 0 and 0.297. And I'll choose this one here, also lies quite well on the line. So if I draw kind of a little triangle, this one here, this point here, is 0.602 and 0.004. Okay, so if I do change in the vertical divided by the change in the horizontal, I can do, I'll call this first coordinate and that one, so I'm going from 0.004 take away 0.297. So that's my change in my vertical divided by the change in the horizontal, which I get to 0.602, and I started at 0. Okay, so if I actually work that out, I've got negative 0.293, all divided by 0.602. Okay, so I've just used my calculator to do the maths. I get negative 0.48671. So for the sake of this, I will say that it's about negative 0.5 is my value of n. Okay, and now I need to go on to work out what k is, and I'll remind you from here that log 10k is equal to the y-intercept. So we will work with that. Again, let me just tuck the paper so I can push it back. So if I go back to this graph, you can see that the y-intercept is 0.297. So I'm going to say that, I'll bring this over here. log base 10 of k is equal to 0.297, which means that k is equal to base 10 to the power of 0.297. Okay, and if I just do that on my calculator, you say I get 1.98, blah, 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 blah. Okay, so if I get k equals 1. Blah, 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 I might say that k is about 2.0. That gives me it to 1 decimal place. Now it's really up to you to do with accuracy. As long as you got the workings right, you'll get all the marks, unless it says specifically what they want you to do it in this question. Okay, so then just to make it nice and clear at the end, I'll say that my relationship between y and x, I will write out nice and clearly. I'll say that y is equal to, so it's meant to be, if we go back to the top, it was k x to the n. So k is 2 in this case, times x to the n, which is negative 0.5. Now some of you might write that as 2 over root x. Okay, and that is how we can find a relationship that isn't just a straight line graph or a quadratic, which we know already. Okay, I'm going to do a bit more of a difficult example, and that'll be on the next video.